Hello, Mr. Aaron, Mr. Ryan, right? So just imagine we have a grid. N times n grid. You know the Rubik cube, right?
Yeah.
This is 1 times 1 times 1. For example, if this number is 1, that means I put a 1 cube here. If you look at it in 3D way. How can I draw it
That looks
better?
like a solar panel.
So look, this is a 2D grid. A Rubik cube, right? Can you give me a Rubik cube?
Okay, I've got it.
Thank you. Yeah, this is perfect. This is 1 times 1 times 1 times 1.
Don't break it like last time.
Okay, this is 1 times 1 times 1. There's a grid. Yeah, turn it this way.
That's an ivy cube.
That's okay. So if this is 1, so it means I put a 1 here. If this is 2, I mean I put it 1, 2 on top. Right? If this is 3, I put 3 cubes. 1, 2, 3. Make sense? Okay. Okay, so let's say if I just put a 1 cube on that, how many surface? How many surface? Surface is that, you know, 6. Good. Counting the top and bottom as well, okay? So if I put 2 cubes on top of each other, so 1 cube here, how many surface?
Do you count these two as 1 or 2?
That's a good question. Yes, 2, but
Yeah, but that's a surface. They're the same like level.
yeah, but it's different. But the thing is that internal one, right? If we have another cube on top, this surface and the surface of another. Do you have another one?
Are you sure?
It's better to have the same size cube so I can draw. I'm not very good at drawing, but
If you have something like this, is this good enough?
that's good. That's good. Okay. So yeah,
That will have 6.
just 1 times 1. Remember, all the cubes is 1, 1, 1. Okay.
This is, yeah, I know this is 2, but this, if you count these surfaces as 6, and this is basically the same, but with a
Yeah.
9.
Okay. Yeah, you understand. Okay. So look, how many surface?
6.
How many surface? How many surface?
10.
That's right, yeah, because these 2 are gone, right? Okay? Yeah? I was so quick, okay? So how do we get 10? Look.
They're very,
1, 2, 3, 4. So there are 8, right?
they're very
And then,
delicate, you know.
yeah, 8 and then 9, 10.
That
Okay?
one's mine, that one's Eric's.
So if I put another one on top, you know how to do it, right?
Yeah.
Okay. Wait, I still, sorry?
I think mine's 11.
Okay, thank
Don't
you.
worry, I remember how to solve it. Same.
Okay, so how many surface if you put it horizontal to each other?
1, 2, the same.
The same, yeah, the same. Okay. So how many surface if you put another one on here?
I'll just get another one.
Yeah.
Like, I'm saying it like this. Like this.
Exactly. Yes. How many surface?
10 minus 1 plus 5. Is it 14?
We want to count the surface. For example, like if I put a 1 cube here, 2 cube here.
Is this the same size?
Yeah. Thank you. Okay. 1 cube here. 1 cube here. 2 cube here. How many surface? Got it? How many surface?
Is it 14?
You count how many? So
1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16.
16. How do you calculate this?
Wait, no. We know this.
Yeah.
We know that is 10,
Yes.
and then we add 1 on top. This one surface like there is gone.
Okay.
So, and then we have 5.
Okay.
There's more than that.
Yeah.
There's 5 surfaces left. So is 9 plus 5. So it's not 10 because this one is gone.
Okay. Interesting. Okay, so you know this one. This is 6, right?
Yeah.
And this is 10, right?
Yeah.
And this is
14.
14. 3 times 4.
1, 2, 3, 4, 5,
14,
6, 7, 8, 9, 10, 11, 12, Oh, yeah.
14, yes. So If there are n, how many?
10 million.
Yeah? Okay, I don't need this because it's too much.
This is 6. This is 10. This is 14.
Yeah?
This is basically.
Okay, so if there are n cubes,
Adding 4.
if there are n cubes, what's the formula? If n cubes, what's the service? N is 1, the answer is 6. N equals 2, the answer is 10. N equals 3, the answer is 14. The n is 4, the answer is
18.
18.
It's
So
adding 4.
adding 4, yes. So how do we know it's adding 4?
So you always have this, the top one and the bottom one.
There are two,
and you
yeah.
always add this 4.
Yes.
You,
How many cubes?
You have one top, one bottom, but
and
you have more of these.
How many of
Which,
these? Which is how?
4 around.
Yes, 4 around. So what's
And-
that? What's that? If n, what's the number? If there are n cube, how many these 4 around? What formula should I put to get this number? You're saying right, there are 2. Okay, so it's 2 plus how many cubes are there? There are 2, right? There are n cubes. So how many surfaces does it contribute? 4 times n cubes, right? This is the formula, right? There are n cubes. The surface is 4 times n plus top and bottom. How about they putting together to each other horizontally? Like here there's 1 and here there's 2. So you know this, right? You know how to calculate this one at a time, right? One at a time. If I say putting together,
Is it 14?
yeah, I'm not looking for an exact number. I'm just looking for the how do we get it. You don't need to tell me the exact number.
Because we know those 2,
Yeah.
that 2 is 10.
Mm.
And then since we know a cube has 6 surfaces, to connect it to the other part, when it connects the intersection,
Mm-hmm.
so it subtract 1 surface like there.
Yeah, subtract. You mentioned a good point. Subtract. Okay. Look, I'm putting the cubes here, right? Put a lot of cubes. If we look at each number, vertically, right? This is 2 cubes. Yeah. This is 2 cubes. This is 5 cubes. We know how to get it serviced individually on its own, right? But the thing is that when you put it together, like this is 1, putting 1 here, and this is 2 here. So they are internal. They are connecting. We need to minus, subtract this part, am I right? Yes?
Mm-hmm.
So we know how to subtract that, right? How many? Look, here this is 1, this is 2. So how many surfaces we need to subtract? Just imagine, here there's 1 cube here.
Connecting the 1 to the 2.
Yeah, here is 1, here is 2. How many surfaces we need to subtract?
2.
2, yes, because look, you put 2 together is 2, right? So, okay, if there are 3 here and there are 2 here, how many surfaces do we need to subtract?
4?
Yes, well, how do we get 4?
I counted.
Okay, so you count it out. How about here? How about, I'm not drawing, okay? How about if this is 100 and this is 200? How many surfaces do we need to subtract? How many surfaces do we need to
Is it
subtract?
298?
2, 9, no?
No, wait, no. Wait. Where? Is it 398?
No.
Where do you get the 9A from?
Nowhere.
You said this is 4, yes, you are right. Okay, how
Yeah.
about this is 3? How many surfaces?
1, 2, 3, 4, 5, 6, 7.
7.
Wait.
You can count, how many?
Yeah, okay. 1, 2, 3, 4, 5, 6, 7.
Why is it 7? No, I mean subtract, to subtract.
Oh!
That's what I was saying. Subtract. I added this bit, and I need to subtract this. I just asked you how many I need to subtract.
There's 1 here, 1 here.
No?
one
Okay,
here,
okay.
1 here, 1 here, 1 here, 1 there.
Ah, okay, I see what you mean. No, okay, so yeah, my questions are not very clear, okay? So what I meant is that we already know these according to that, right? So
Yeah.
this is how many? 3 is 14, right? 14, yeah? Am I right?
Yeah.
14 surface of this bit plus 14 of surface of this bit. But they are common part in the middle, which we shouldn't count it. We need to minus something. So how many we need
The
to minus?
minimum.
The minimum, yes, it's a minimum, but
And the max.
And isn't it the tower's minus 1 because 3 minus 1 is 2 and there's 2 there.
no, I just say this bit,
Yeah.
this bit.
Yeah, I know.
So how many of these?
Is the minimum tower.
Minimum, there are 3 towers here, there are 3 towers out here. So how many I need to subtract from 14 plus 14? 2 of each one. 1, 2, 3, 4, 5, 6. You need to subtract 6, right?
Yeah.
Okay, so is it times 3 times 2, right? Does it make sense?
Mm-hmm.
Okay, so here, 100. Here is 100. Imagine this is 100. This is 200. How many I need to subtract? Subtract, okay? Just this bit. Just this common part. How many I need to subtract?
Is it 200?
Yes, now get it. Okay, another one, 1,532. How many I need to subtract?
Is it 1,064?
That's right, yes. That's what I want to hear. Okay. So this is horizontally, right? Look, this I'm considering. Here, 1, here, 2. Now I need to subtract this bit, right? Yeah, the minimum of it. Okay. Okay, so now here, 2 and 4. I need to do the same, right?
This is vertically and this is horizontally.
Yes, yes, yes. But this is the 3-dimensional. Just imagine this is a 3-dimensional. I put a 1 cube here. I put a 2 cube on top of here. I put a 2 cube on top of here. I know the contribution for each tower, right? Each tower, this formula, right? But I need to subtract this common part, right? These are hidden. These are hidden. Am I right? Does it make sense now?
Yeah, but if a cube is on the edge, then
On the edge, yes.
it doesn't subtract this.
That's right, that's right. I added all of it together, right? 1 using this formula. 2, I add it all together. And for this edge, common edge, right? If there's a number above it, then I need to subtract this part. If it's a number on the left, then I need to subtract this part, right? We compare the minimum. Get the minimum. Okay, so now it's 3 towers. 3 towers, I need to subtract 6. Here, 2 towers, I need to subtract 4. Okay, so how many I need to subtract here? How many I need to subtract here?
8.
How many I need to subtract here?
0.
Yeah. How many I need to subtract here?
4.
How many I need to subtract here?
8.
Yeah, well done. Now you get it, yeah? So the idea is to add it all together and subtract these. This bit has 2 sides, either on the top or on the left. F, N. Answer at the beginning is 0. For row in range N. For column in range N. This is the grid, okay? G, okay? Now answer plus equal G. GRC. This is the number, right? And the contribution is this one, times 4 plus 2. If R is bigger than 0, we need to minus, subtract. If the row, if it's from the second row, right? This is R, this is C. If it's from the second row, I need to subtract this common part from here, right? Answer minus equals the minimum of GRC and GR minus 1C times, what's the number here?
The minimum times 2.
2, yes. And if it's the second column to the right, if C bigger than 0, answer minus equal mean GRC and GRC minus 1, right? C minus 1 is the number on the left. And times 2. And return answer. I give you this to count. It's hard, right? It's hard to imagine, right? You need to count. But the idea becomes simple. If we add the contribution for n cubes tower, how many surfaces? It's n times 4 plus 2. Plus 2. Plus 1 here. Plus 1 here. If we add these, but we also need to get rid of the common parts, right? So the common parts, here this is 3, this is 4. How many we need to subtract?
6.
6 for here. And
Yeah.
how many for here?
4.
The time complexity, O(n) squared, easy. N squared, O(n) squared. N times N, O(n) squared. Or O(n), where N is the number of the of the cells in this grid. Okay, so what have you learned today?
About this, we have this platform for cubes to go on.
Yeah, cubes.
And we want to
Count
We want to count the surfaces,
number of surfaces. Yes.
number of surfaces.
Uh-huh. And what's the idea? How do we do it? What's the idea?
counts.
So we find out the common parts, which is the minimum times 2.
Minimum times 2, yeah. So
Yeah.
look at here. Minimum is 1 and 1. Minimum is 1 times 2 because here is 1, here is 1 times 2. Okay. If there are another one here, minimum is still 1, right? It's times 2. Okay. So the idea is that to add the numbers with this formula. For example, this is 6 plus 6 minus 2. Make sense? Yeah. This is the idea. Okay. Okay. That's it for today. Bye bye.
Bye.
Bye. Bye bye.